In this video, we're going to talk about solving for a particular variable when we have a linear equation present, and then also if there isn't an equation already present, we're going to formulate one and work through that. So word problem time, in other words. Okay, so first thing we see is just a simple example here where we're talking about gravitational potential energy. It's an idea in physics talking about or related to conservation of energy. But anyway, in symbols, we can express it as u1 minus u2 and equals mg h2 minus h1. And right now, the idea isn't necessarily to focus on what each of these symbols means. It's just right now we just want to solve for h1. Okay, so ignore the meaning, just focus on the task. Okay, so that means ideally what I want to do is get at this h1 so that at the end my answer looks like h1 equals something. So isolate it. Okay, first thing I see here, okay, I'm going to write it down. u2 minus u1 is equal to mg and then h2 minus h1. Okay, first thing I see is that, okay, well, if I'm solving, I'm really kind of going through order of operations in reverse. So I would normally, according to order of operations, I would work inside parentheses. Okay, do the subtraction. So in parentheses, subtraction, and then I would multiply by mg, right? And then I would get u1 minus u2. Okay, but now as I kind of work through order of operations in reverse, I'm going to get rid of this mg first, and that requires us to undo the multiplication, or do division by m, not n, mg, and so then the next step in my equation, I get u2 minus u1 over mg, and I just have to check for space here. Okay, we're good. Is equal to h2 minus h1. And I drop the parentheses because there's no longer any need to have them since it's just h2 minus h1 on the right-hand side. Okay, well, next I'm going to subtract h2 from both sides because, again, I want to isolate h1. So I'm going to have u2 minus u1 over mg minus h2, okay, so I'm just coming up there, is equal to minus h1. Now I'm almost done. The only thing I need to do is completely isolate h1, so get rid of the minus sign, which is to say I can either multiply or divide. I'm going to multiply by -1 to both sides. And again, I'm doing this because whatever you do to one side, you have to do the other when there's an equal sign present. So my final answer is u2 minus u1 over mg, negative of all this, minus h2 is equal to h1. And from here, if you wanted to distribute the minus, the negative sign to each of the two terms in here, feel free. I'm not going to. Okay, so you're going to see some examples in Hawks and other places where you might just have to solve an equation for a particular variable. Otherwise, you might see some applications, and a couple applications that we're going to see in particular are related to distance, rate, and time, and interest. The one that we're going to mostly see is this distance one. Okay, so I call this equation DIRT. Okay, so it's distance, d, is equal to rate times time. Okay, and so I just imagine there's a little I here, that's all. But another thing that we will come to see is that this rate, we're actually going to call this either a speed or a velocity, depending on the context, and if we have vectors or not. Topics for later. But rate is often going to be expressed as a speed. Okay? In the second equation, I is talking about interest that you earn on some investment. So this is typically in a banking type context. And so I is equal to the principal, which is the initial amount. Okay, so sometimes that language of principal, people are thinking, oh, like a principal at school. Nope. This is like the initial amount that you invest. Okay, and then rate is your interest rate, and time is typically in years. Okay. Could be in months, though, if you have a good bank. And the big thing here that we need to be careful of is, as always, watch for units. Sometimes it might be in years, months, etc., or it might ask for a particular unit, so be mindful of the units. Okay, so this is a big word problem, okay, and I know we love word problems so much. What we really want to do is just kind of take a minute, read it, and then I'm going to say maybe get a picture going. So I encourage you to pause the video and get a picture going. Okay, and so hopefully you had a chance to do that. So if we imagine that the warehouse is right here in the middle, and then it says one travels due east. Okay, so one truck is traveling due east at 65 miles per hour, and then the other one is traveling due west at 55 miles per hour. That's a P. And we want to know how many hours. So we want hours. We want to know hours when they will be 500 miles apart. Okay, so I'm just writing some blurbs down, miles apart. Okay, and I just have to do that to keep track of the information given to me. Okay, so now this, let's see, hours is a time, right? So time, I know that 500 is a distance. Oh, I'm probably going to use the DIRT equation. So distance is rate times time. Alright, and so let's see, distance, I'm just going to plug in some things here. 500 is equal to, okay, I don't know the rate yet and I don't know time. Okay, well, that's all I could plug in. So now I need to figure out what I need to figure out. Okay, so of the information given here, rate and time, my final answer needs to be something in time. That means that I need to figure out the rate. So to do that, what I end up doing is, okay, I'm thinking like a rate is, in this equation, typically a rate is going to be expressed as a distance unit over a time unit, right? And so distance, here's in miles, oh, an hour. So we're talking about speed, yeah? And so now I'm going to say that the rate is going to be 120. Now I want you to pause the video and see if you can justify to yourself why it's 120. Okay, here's why it's 120. If I think about this, after 1 hour, the truck traveling east has traveled 65 miles, right? It's 65 miles per hour, so they travel 65 miles in an hour. In 1 hour, that is. And then same thing is 55 miles per hour. Okay, so if I think of like the total number of miles they travel in if we know it's 1 hour, how many total miles are traveled between the two trucks? It's going to be 55 plus 65, okay, or 120 miles per hour. Okay, so that's where the 120 comes from. And then I just need to double check again the units. Am I okay with units? 500 is in miles, this is miles per hour. If I work with this, it is going to give me hours, so I'm going to be golden. Okay, solve for t divided by 120. Okay, and doing the math here, I got like 4.16 repeating hours. Okay, so now this is good. What I actually prefer is a little sentence, so I will say, in the limited space that I have is after 4.16 repeating hours, the trucks are 500 miles apart. Okay. And, well, that happened. Okay, so here, the key to this problem was really getting a diagram going and then figuring out what the information is that is given to you, what quantities they represent, and then identifying an equation, right, that can help us out, and then substituting information in appropriately. Okay, that's the big idea here. And so when you're working with linear equations, always kind of try this general method. Picture, identify knowns and unknowns, get an equation, and implement the equation, and then interpret. Alright, we'll get some practice with this in class.